Alright, my name is Josh Holland, and this is my project update for the design optimization of a joined aircraft wing. The goal of this is to optimize the design to minimize the drag and structural weight and maximize the fuel volume, subject to the system boundaries there below, which are primarily the airfoil shape, the structural locations, and some material properties. The approach used is to initially solve or optimize the airfoil shape using a gradient-based programming method I found from MATLAB online. It takes in an airfoil input, uses the conjugate gradient method, and then it inputs and analyzes the airfoil shape to X-foil. Then it's going to take that airfoil shape and analyze the wing load distribution, and then after that the aircraft structure the wing structure will be optimized in HyperWorks. It'll be topology optimization. It's going to be a simplified wing box that's modified, and it is a simplified wing box that's modified. And so step one completed so far. Minimize the drag subject to these parameters right there. It starts off with asymmetric airfoil, and then it closed on this gold airfoil shape below. This is a high-level process flow. So NACA 002 is what the initial input was. So then it analyzed it in X-foil, determined whether or not there's an optimum, and then spun it back through the optimization. So the loads analysis has been completed as well for the front and back wings. The total lift produced 9,000 pounds for this configuration, and then the drag coefficients found there. And then the third step, which is a step I'm currently working on, to minimize the weight to volume ratio subject to the parameters right there. Initially I put in this simplified wing box configuration for the front and aft wings in the bottom right. That actually presented some challenges for HyperWorks due to the complexity of the model and the size of the mesh elements produced. So I went back and simplified it. They're still having HyperWorks is still having some issues producing this because of the student version that I have. But so far, I've been able to reduce the load cases and come up with this initial optimization. This isn't a complete representation of the wing box, but so far it's turned out pretty well, and it looks like it stopped calculating before it closed onto an absolute volume minimum due to the number of iterations. So the next steps will include correcting the HyperWorks model errors that have been in there for the topology optimization, run through more iterations of HyperWorks, and put some more fidelity into the airfoil shape optimization process flow that was in the presentation earlier, and then complete the report and final presentations. Also, if time allows, I'm going to do a little bit more with the wing optimization in MATLAB for the wing joint location, and then potentially a larger, more realistic HyperWorks model.